So today po, we're going to discuss the solar-powered home grid mode. And the first I'm going to tell is the working principle. Working principle of solar panel. Solar panel works by generating electricity when particles of sunlight or protons knock electrons from atoms, setting them in motion. This flows this flow of electrons is electricity, and solar panels are designed to capture this flow, turning it into a usable electric current. Pag yung sunlight hits the solar panels and creates an electric field. The electricity generated flows to the edge of the panel and into a conductive wire. The conductive wire brings the electricity to the inverter, which it transforms from this electricity to AC, which is used to power buildings. So that's how solar panel works. Grid-tied systems store energy in the power grid. The solar panel harvests turn to sunlight, DC or direct current. The inverter turns DC into alternating current or AC. During the day, solar panel will run through a switchboard thus powering appliances. So ito po, ganito po siya nag-work. Ito po yung grid-tied solar electric system. Ito po yung sunlight na tumatama sa ating photovoltaic panels, and yung protons na natatanggap galing sa sun ay nagiging DC electricity na dumadaan sa main panel po, tapos sa meter. Tapos microinverters mounted on each PV panel will convert the DC voltage from the PV panel to voltage suitable for your home. Tapos ito po yung AC electricity. You do not use it, send back to the grid. And here are the three configurations po: grid tied, off-grid, and hybrid. Yung first one po is grid tied. Solar power system is connected excuse me po, to the home and to traditional electricity utility grid. This type of solar power system does not include any storage battery. So ito po yung hindi na-store yung power ng sunlight. And the second one is off-grid. This type is a standalone system that is completely disconnected from the electric power grid. It contains a large set of battery pack which stores energy during the day to be used at night at times when sunlight intensity is low. So ito po, yung off-grid po, siya po yung may malaking battery packs para po ma-store yung energy natin sa umaga, yung init po sa umaga para po yun po yung nagagamit natin sa gabi. The last one is hybrid po. A grid intertied solar power system is also connected to the traditional utility power grid, which contains battery backup. The addition of a battery backup enables the system to work when there is a power interruption. Second chapter po is parts and function. So the first one is solar panels. Solar panels, also known as PV panels, are used to convert light from the sun, which is composed of particles of energy called photons, into electricity that can be used to power electrical loads. So solar panel can be connected together to create a solar array. The output of a solar array is computed much like a battery. Series connections increases the voltage while the current remains the same. Parallel connections increases the current while the voltage remains the same. When you connect the multiple panels together, the power of the overall system increases, regardless of whether they are connected in series or in parallel. Each panel on the next slide is rated at 12 volts and 10 amperes. Calculate yung total voltage of the power and the total power. Ito po yung ating mga solar panel. Monocrystalline solar panels and polycrystalline panels. Ito po yung silicone arrangement. One pure silicone crystal. Mas mahal po yung monocrystalline panel sa black hue. And the efficiency po is most efficient. And the lifespan po is mas mahaba din. And temperature coefficient, lower temperature coefficient, making them more efficient in heat So, ito po mas expensive is mas mahaba po ng buhay and mas nakakasahan po. And yung polycrystalline po is many silicon fragments melded together and less expensive. Panels have blue use, less efficient, and mas short po na siya mga gamit, which is 20 to 35 years, and higher temperature coefficient making them less efficient in heat. Ito po yung mas muna sa atin nakikita yung polycrystalline panels, yung po yung kulay blue, and yung monocrystalline po is yung black, medyo itim-itim po. The second part po is inverter. A solar inverter or PV inverter is a type of electrical converter which converts the variable direct current or DC na po yung direct current output of a photovoltaic or PV solar panel into a utility frequent alternating current that can be fed into a commercial electrical grid used by local off-grid electrical network. This type output voltage in the form of sine waves. Utilities also provide sine wave output because of this. Your sine wave inverters are usually needed if you're going to be tied to the grid. Typically, you'll need your sine wave inverters for sensitive equipment, newer TVs, CH, light bulbs, and appliances with AC motors, microwaves, and refrigerators. Your sine wave inverters are capable of producing cleaner, smoother, quieter, and more reliable electricity to operate appliances and electronics without interfere. Energy cells a range of your sine waves inverters of varying capacity to fit your solar installation and your energy needs. In pure sine wave inverters, the AC power produced by the inverter very closely matches an output sine wave. In modified sine wave inverters, the polarity abruptly switches from the positive to negative when looking at the wave. It has a stair-step square pattern where the polarity is flipped back and north. The choppy wave can negatively affect more delicate and sensitive equipment. If you have medical equipment you need to power, such as CPAP machine, you won't be able to use a modified sine wave inverter. Additionally, in many cases, you'll hear a humming device attached to a modified sine wave inverter. The only advantage of this type over the pure sine wave is that this is much cheaper. So yung inverter po na, hindi po siya magagamit pang malakihang machine. Meron lang, pinipili lang din po yung kaya niyang mapaggamitan. So yung third part po is DC circuit breaker. The DC circuit breaker, sometimes referred to as a PV disconnects, are placed between the solar panels and the inverter, or in some cases built into the inverter. Just like a typical CB, it acts as an overcurrent protective device. Short circuit on the part of solar array may produce a high value of current which might damage the inverter or the system as a whole. Before it happens, the DC circuit breaker acts as an automatic switch, disconnecting the inverter from the solar array. The next one is DC surge protection device, or SPD. The DC SPD are placed parallel to the DC CB. SPD generally protects the system from power surge, or more appropriately called voltage transients. SPD redirects this excess power to the ground. In PV systems, since solar panels are heavily exposed in the environment, transient voltage is primarily caused by lighting, whether directly or indirectly. Multiple interconnection within power cables is very susceptible to electromagnetically induced transients where power surge could also arise. Next is AC circuit breaker, or RCBO type. The AC circuit breaker are placed after the inverter. Just like a typical CB, it acts as an overcurrent protecting device due to short circuit and overloading. RCBO stands for residual current operated circuit breaker with overcurrent protection. In the RCBO type, it has added protections since it can sense earth leakage current where the typical breaker cannot. It has the capacity to trip when somebody touches a live wire. Thus, protecting the people around. So, ito po, AC circuit breaker siya po yung may overcurrent protection. And the next one is AC surge protection device, or the ACSPD, or the ACSPD. The ACSPD are placed parallel to the ACCD. Just like the DCSPD, this serves as protection against transient voltage, but this time on the AC side on the PB system.
Hey sir, this is Janel B. Gonzalez and this is part of my report. Time delay switch. Time delay switch is a device that delays the turning on of any electronics device for a desired time interval. It serves its useful purpose usually when brownout occurs, when power have already been restored, but there's the tendency of power surge which may damage the system if it is turned immediately. The net metering pack. Net metering allows customers of distribution utilities to generate electricity for their own use. Any electricity generated that is not consumed by the customer is automatically exported to the DU or distribution system. The DU then gives a peso credit for the excess electricity received equivalent to the blended generation cost, excluding other generation adjustment. Is net metering already available in the Philippines? The net metering program is available only to on-grid distribution system or disconnected to the transmission grid. The program was approved by the Energy Regulatory Commission on May 27, 2013 and took effect on July 24, 2013. This resolution was published on July 2013 in newspaper of general circulation in the country. How will my DO meter may import and export energy? The DO of Endeavour University or DU may install a single unidirectional meter that can meter both import and export energy. The total regeneration shall earn for the host DU-RE certificate which DU can use to comply with its renewable portfolio standards RPS obligations. Who are qualified to participate in the net metering program? Customer in good credit standing in the payment of their electric bills to their then given utility district or DU are qualified to participate in the net metering program for renewable energy. These customers are referred to in the roles as qualified end user or QE. Consequences of not applying for net metering. In the case that solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. It means if a solar power system is constructed but no application for net metering is submitted, all surplus energy sent to the grid will be billed to the client. Example is when the system is rated at 5 kilowatts and the load consumption is only 4 kilowatts. The system will have an excess of 1 kilowatt which will be sent to the grid. This excess energy will pass through the meter and hence will be billed to the owner. Is there any other way besides net metering that a customer having a solar power system producing excess energy during the day and yet will not pay for it? This can be achieved by using an inverter with limiter. This device limits the power that the system will dissipate. It automatically detects the maximum power that the system can provide without the excess being sent to the grid. An inverter with limiter can be used to do this. This gadget controls how much electricity the system uses. It detects the maximum power that the system can offer without sending the extra to the grid automatically. This is an illustration of the solar-powered home grid tied which you can see each part, the DC, SPD, DCCB, DC input, AC outlet, TDS, AC, SPD, RCBO, and panel board. DC and AC electrical wire sizing. Number 1. TW or thermoplastic wire. Moisture and flame retardant. This type of wiring is commonly used for residential and light commercial construction in many countries. 2. THW, thermoplastic, heat-resistant wire, moisture-resistant, and flame retardant. It is usable in both wet and dry condition, as well as both indoor and outdoor use. THHN, or thermoplastic high heat resistant nylon coated, designed for specific insulation material, temperature rating, and condition of use. Suitable for dry and damp location. It's designed with a specific insulation material, temperature rating, and condition of use for electrical wire and cable. Number 4. THHN or THWN-2 or thermoplastic high heat resistant nylon coated is similar to HHN or thermoplastic high heat resistant nylon coated wire, except it is water resistant, adding the W into the acronym. THWN is rated for up 167 Fahrenheit or 75 degrees Celsius in wet environments, but its successor, THWN-2, is rated for 90 degrees Celsius in both wet and dry environments. Historically, THHN and THWN were separate wires, but now you typically find their capabilities combined in THHN and THWN-2 design. So most wires in this category carry a dual rating and a mark and approved for both applications. Here's a breakdown to help understand the abbreviations. T. Thermoplastic insulated cable. H. The wire is heat resistant. Double H. The wire is heat resistant and can withstand higher temperature. W. The wire is water resistant. N. The wire is nylon coated. PB wires. This type is an exclusive kind of wire created for PB applications. These cables behave extremely well in very hot temperatures and other harsh environmental conditions. Its special characteristic compared to other wire is its insulation and outer sheet, which is made up of XLPE or APR. XLPE is an acronym for cross-linked polyethylene. XLPE is a thermosetting polymer, meaning that the material polyethylene PE or PE is cured under heat and in that process forms bonds in all directions, forming a three-dimensional matrix. APR means ethylene propylene rubber. It is a single conductor wire used to connect the panel of photovoltaic electric energy system. This is the illustration of different sizes of AWG that can be differentiated by their gauge. There are 3 gauge, 6 gauge, 8 gauge, AWG, and so on. This section represents the temperature rating of conductors such as copper and aluminum. This table of temperature rating copper conductor represents the AWG sizes that they are using and the type of wire of each AWG. And lastly, now, this is the table of ambient temperature other than 30 degrees Celsius. Multiply the allowable ampacetides specified ampacetide tables by the appropriate correction factor shown below. As you can see, that each ambient temperature have equivalent temperature rating of conductor. So, as the ambient temperature change the equivalent temperature rating of conductor also.
Good day everyone, my name is Juan Aurelio Diaz from BSc 8 Ang topic po na di-discuss po namin ngayon is the solar powered home or the Great Tide. Ito, makikita po natin dito yung the table of the solar powered home. Pumapasok dito yung size, cross-sectional area, weight, overall diameter. First, sa size po, ang pumapasok dito is AWG or KC mile and CIR miles. Ang AWG daw po is the American wire gauge. Sa cross-sectional area naman daw po is the square inch and square millimeters. Sa weight naman daw is LB or 100 feet and the kilogram or the kilometers. Sa overall diameters is the inch and millimeters. Yan daw po yung example. First, look for the ISC rating of PV cells. Ang ISC daw po is the short circuit current. Second, multiply by the two safety factors, reagents, and the continuous duty. Refer on the table of 310.15, multiply by B or and the 16 for the size of wire. Refers on the table of 310.15, multiply by B2 and A for ampacity correction due to ambient temperature more than 30 degrees Celsius. Refers on the table 310.15, multiply by B, 3, and C for ambient temperature adjustment due to conduit or desired distance from the probe. Refers on the table 310.15, multiply by B, 3, and A for adjustment due to more than 3 wires inside a conduit. Find the adjustment due to voltage drop, and the value of contained obtained in the last step will be the basis for the size of wire to be used in the PV system. Ang PV system is the photovoltaic. This is the example or the photovoltaic. This is the example of photovoltaic in the brand. Yan po. Find the proper wire size for a grid tied PV system, consisting of the three GA solar panels and connected in the series with the spec at the previous slide. Ang GA solar panels daw po, ito po yung half-pot cell panels, a technology that increase their energy output. Ito daw po yung isang technology na nagpapataas ng output ng kanilang energy. Step 1. Look for the ISC rating of PV cell. Short circuit current is equals to 9.75. 9.75 ampacity is equals to intimate partner violence. Step 2. Multiply by two factors, reagents, and the continuous duty. IPV or the intimate partner violence is equals to mu is equals to 9.75 ampacity multiplied by 1.25 multiplied by 1.25 is equals to 15.23 ampacity. Step 3 refers on the table 310.15 multiplied by B and 16 for the size of wire. The table indicated the number of 14 THHN or the thermoplastic high heat resistant nylon coated with an ampacity of 25 ampacity. Since number 14 AWG is not the best practice for PV system, use the number 12 THHN with the ampacity of 30 ampacity. VD is equals to 2 IR and R equals to KL over AA. Find the proper wire size for a grid-tied PV system consisting of 3 GA solar panels connected in series with specs at the previous slide. Ang step 6 daw po is, since there are only 2 wires inside the conduit, this step can now be bypassed. Step 7, adjustment due to voltage drop. Less than 3% use formula. VD or the voltage drop. Ang voltage drop nga daw po pala ay nagde-depend daw po siya as the amount of the voltage less than that occurs through all or parts of the circuit due to conductors. The voltage drop is equals to 2 IR and R is equals to K multiplied by L and A. VD is equals to 2 multiplied by 9.3 multiplied by 12.9 and multiplied by 25 over 6,530 is equals to 0.92 volts. Percent ay VD is equals to 0.92 over 32.26 multiplied by 100% is equals to 2.85%. Since 2.85% 85%, less than to 3%, our selected number 12 wire will fit the system. Dahil daw po malapit ang 2.85 sa 3, mas mabuti daw pong gamitin ang number 10, thermoplastic high heat resistant nylon. Ito po pala. But since 2.85 is a bit near to 3, it would be better to use 10 THHN wire for additional safety factor and for future expansion. Dahil daw po malapit ang 2.85 sa 3, mas mabuti daw pong gamitin ang number 10 thermoplastic high heat resistant nylon coated wire para daw po sa additional safety factor and for future expansion. On the previous problem, in case that voltage drop exceeded 3%, let's say 5%. The additional computation is as follows. Since the initial selected wire is number 12, THHN or the thermoplastic high heat resistant nylon coated, make a one step higher adjustment. Select initially number 10 THHN. VD or the voltage drop is equals to 2 multiplied by 9.3 multiplied by 12.9 multiplied by 25 over 10,380 is equals to 0.058 volts. Percent voltage drop is equals to 0.58 over the 32.26 multiplied by 100% is equals to 0.18%. Select the number 10 THHN as the final wire to be used in the system. Okay, ang meaning daw po is the direct current constant. This is the constant representing the direct current resistance for 1,000 circular miles. Conductors that's 1,000 feet long at an operating temperature of 75 degrees Celsius. The direct current constant value usually used for copper is 12.9 ohms and the 21.2 ohms for the aluminum conductors. The K constant is the suitable for alternating current circuits where the conductors do not exceed number 1 over 0. This is the table of the windy nation sa brand or the example. 2% voltage drop charge, and the fit one-way FA of wires. With the WG is equals and the capacity of amps and the RRE amps. This is the normal residential usage. Sa first po tayo, sa 3 over 0 gauge, pumapasok daw po dito yung 200 amps and the service entrance. Sa 1 over 0 gauge is 150 amps, service entrance and the feeder wires. Sa 3 gauge is the 100 amp service entrance and feeder wire. Sa 6 gauge is 55 amps feeder and the large appliance wire. 8 gauge naman is 40 amps feeder and the large appliance wire. Sa 10 gauge naman is 30 amps dryers, appliance, and the air conditioning. And the 12 gauge is 20 amps appliance, laundry, and the bathroom circuits. And the 14 gauge is the 15 amps general lighting and the receptacle circuits. Sa solar PV usage, ito daw po, ang solar daw po yung kumukuha ng energy papunta sa charge controller and battery bank and to AC devices. Ang meaning daw po ng GTI is the global tilted irrigation or irradiance. Yan po example na normal residential usage. This is the minimum recommended cable size or cross-section area of two core cable for 24 volts renewable energy system. Voltage loss under 5%. Pumapasok dito yung maximum watts from the solar panel or the array. 1 meter or the 3.25 feet. 3 meters is the 3.85 feet. 5 meters the 15.4 feet. 10 meters 32.8 feet. 15 meters is the 49.25 feet. And 20 meters 65.61 feet. For example, sa maximum watts from the solar panel array, pumapasok dito yung 40 watts. Tapos makukuha niyo sa 1 meter or the 3.28 feet is 0.5 millimeters squared. And susunod 0.5 millimeters squared. Hanggang sa 10 meters makukuha niya is 1.0 mm squared, and the 1.0 mm squared hanggang sa 20 meters makukuha niya is 1.5 mm squared. Ito, parang ganun lang din dito sa din yung example niya. And the people. Ito din yung standard ampere rating. The table 240.6 standard amps rating for the fuses and the inverse time circuit breakers. Dito naman po. First, things to consider in sizing a CB4 PV system is the ruling in PEC. Ang PEC daw po ay Pedernales Electric Cooperative or Pedernal Electric Cooperative, which state that PV circuit current is the continuous thereby. The minimum OCPD, ang OCPD daw po is overcurrent protection devices. Rating is 125% of the maximum current or PEC 2017 Article 6.90.2.2b and Article 6.90.2.3b. Therefore, in the reference to the problem is in conductor sizing. On the DC side, the max current is the 15.23 ampacity multiplied by 125%. That is 19.04. Use 25 ampacity CP. On the AC side, let's assume that the inverter rating is 1.5 kW and a current of 12 ampacity multiplied by 125%, that is 15. Use 20 ampacity CB or RCBO. Ang RCBO daw po is residual current breaker with overcurrent. The rule is simple in sizing of surge protection device. Basically, the UC or the utility scale solar rating of the SPD or the surge protection device should match the system voltage or a bit higher. 15% minus 25% for SPDs to attain a longer lifespan. Therefore, in reference to the problem in conductor sizing, for the DC side, use SPD with UC rating of the 100 volts to 120 volts. For the AC side, use SPD with the UC rating of 230 volts and to 275 volts. Ang meaning daw po ng or the IN is the nominal discharge current. Sa IMAX or IMAX, maximum discharge current. UC or MCO, sa UC na is maximum continuous operating voltage or the MCOV. Yun yung meaning kanina ng UC. And yung UP ay ng MCOV. Yun yung meaning nun. And the UP is the voltage protection rating or VPR or surge voltage rating, SBR or clamping voltage. The annual sun hours. Yung una po is the greater than 7.0, 6.5 to 7.0, 6.0 to 6.5, 5.5 to 6.0, 5.0 to 5.5, 4.5 to 5.0, 4.0 to 4.5, 3.5 to 4.0, and 3.0 to 3.5, and 0 to 3.0. Compute, ito daw po yung compute for your monthly average kWh use 300 kW per hour per month. Convert to daily usage for convert to daily usage 300 kilowatts per hour per month per hour per month is 30 days. 10 kilowatts hour per day is equals to 1,000 watts hour per day. Note, in Philippines, peak sun hours is equals to 5 hours a day. For solar array rating is 10,000 over 5 is equals to 2,000 watts. For zero bills, assurance is 2,000 multiplied by 1.1 is equals to 2,200 watts. Number of the panels is the 2,200 multiplied by 300 is equals to 7.33 is equals to 8 solar panels. Ilang po?